Okay, welcome to the Physics 101 Lecture 3, and today our topic is motion in one dimension. And after that, we will study motion in 2 and 3 dimensions, which is known as projectile motion. I think that next week we will continue with the next topic. Today our topic is motion in one dimension. And this topic is also very simple, and I know that you already know it from the high school. It will be easy for you. And after the lecture, I will upload the lecture slides and also lecture video on the LMS, on the Moodle page. So, motion along a straight line is one example for the one-dimensional motion, and there are important quantities for the motion. What are they? Position and displacement, and also average velocity, average speed, instantaneous velocity, and instantaneous speed, and also free fall acceleration. Or check my personal web page open.com. But the new lecture notes and slides are available only on LMS, on the Moodle page, okay? And so what is the motion? So every around you. So there is a motion is one of the main topic in physics. So when you look at from your window, you will see that cars are moving and also planets are moving. Also people are moving. So everything is moving. So it makes that motion. And for simplification, you consider a moving object as a particle from their center of mass. So it moves like a particle, a point object. So if you think, so it doesn't matter if their shape, so they can be. What is important? Important is their initial position, their position and velocity and other quantities. So their shapes are not important for this type motions. Are you hearing me?
Yes, we are.
Yes, hocam.
Are you hearing me? Because it said that hold on, looks like something went wrong. Okay, if you hear me, okay, there is no problem. Okay, so motion is everywhere. So for example, from the one city to another city, you use plane and change your position. So when you change your position, it means that you make a move. And there are 4 important quantities for the motion. So what are they? Displacement, velocity, time, and acceleration. Displacement and velocity are vector quantity, and also acceleration is a vector quantity, but time is scalar quantity. So vector quantities has direction, but scalar quantity has no direction. On speed is also scalar quantity. So what they? So one-dimensional motion, you can define the as R. This position vector is also this vector, so you must show it by bond fold or with arrow. So it means that this is a vector. So motion can be defined as the change of position in time. So how can we represent motion? First of all, you must define a starting point. It is also known as origin. So origin is our 0 point. Not choose it. And relative to the origin can be right, up, or left, down. If you use the XY coordinate system, left and down are negative direction, right and up are positive direction. And also it depends on the time. So it is when t equals 0, r does not have to be 0. So your initial position can be 5 meters, 3 meters, it doesn't matter. So, and another important thing is SAI unit of the position vector. What is the SAI unit for the position? So the right direction for the one dimension. Yes.
Sorry, but your voice is not clear. There is lag in your voice.
Yeah,
Really?
it's a
Okay, let's try another.
not
Okay.
obvious.
Yes, maybe my internet, there's a problem. Okay, 1 minute. I changed the microphone. Okay, how can you hear me now?
It's better.
This is better.
Yeah.
Yes,
Okay.
a little bit.
Now I am using my mobile phone. Maybe it is better. Let me weird also. Because the internet connection. Okay, are you hearing me?
Yes.
Yes. Yes.
Okay, very good. Now, so how can you represent the position along a straight line? You must first define the starting point, which is known as origin point. You can use it as 0 point, but it cannot be also 0. If you want, you can choose another point for the starting point. And for the one-dimensional motion, if you are moving on the x-axis, the right side is positive direction and left side is negative direction. And another important thing is also here, for example, your initial position is this one. R is equal to positive 2.5 meter I hat. I hat is for what? I hat is for positive x direction and minus I hat is for negative x direction. This is your initial position. And let's say that this is your final position, which is equal to minus 3 meter I hat. So the question is, what is your this position, or how can you find your displacement? You know this is initial, that's right. This is initial position and this is final position. Okay, now by using the initial and final positions, we are going to find your displacement. So what is the displacement? Displacement is a change of position in time. So displacement is found from this equation. Delta R is equal to R final minus R initial. Always when you see this delta, you must make final minus initial. For the displacement, this is a vector quantity, so you are making final position minus initial position. And F stands for final and I stands for initial. So the displacement is a vector quantity. So it has both magnitude and direction. It can be positive or negative. And the unit for the displacement is meter. For this example, R1 is the initial position. So the initial position is, this is initial, and R2 is final position, minus 2 meter I had. So let's find what is the displacement. Displacement is, for this particle, is equal to delta R, final position minus initial position, minus 2 meter minus 2.5 meter is equal to minus 4.5 meter I had. So we found what? Displacement. So for the displacement, you must always use the direction I hat, J hat, K hat, and also it is important to take their difference of final position minus initial position. So for the other example, this time your initial point is minus 3 meter I had. This is your initial point, and your final point is positive 1 meter I had. So what is your displacement? And your displacement delta R, in the book and also lecture note, they use the bold font so that sometimes they don't use the arrow on the letter, but when you are doing an exam and writing by your hand, don't forget to put arrow. So because arrow show that it is vector quantity. So delta R is equal to final position minus initial position. So final position is 1 meter minus 3 meter I had. So minus become positive 3 meter, and totally it is 4 meter I had. So the displacement of second particle is 4 meter I had.
Doctor, even I must have vector, right?
What please? Sorry.
For I vector, right?
Yes, this is vector. When you see I hat, J hat, K hat,
Yes.
it means that vector. Okay.
Okay, thank you.
This is important. Okay. Another thing is distance and position time graph. In this graph, what you can see two cars. For example, here are A and B cars in the first figure, and you can see their initial position. Initial position means when t equals 0. When t equals 0, car A is at 30 meter position, and car B is at 10 seconds at 52 meter position, so on. You can see also from the other this table for the other cars, for example C, D, E, F, and their initial position and also which time, but on the second table, what you see, this is the xt graph. On the y-axis, there is a position x, and on the x-axis, there is a time. For example, for car A, its x is 30, but t is 0. Okay, so this x is not. You can write it xt or tx. It depends on you. But this is xt graph. So first, on the y-axis, we write the position, and x-axis we write what? We write the time. So by using these plots and graph, you can also find displacement. Okay, let's look at find the displacement, and from point A to point B. Point A is initial point. So initially your car is here, and after that it moves to the here. Okay, because how can you understand the initial? Because time is always passing in one direction. Okay, always increasing, not decreasing. So that point B is final, point A is initial. How can you find displacement? Final position minus initial position. So final position is 52 minus initial position 30. It will be equal to 22 meter I hat. Okay, they are in the one dimension, so only we use I hat direction. And from A to C, if you look at here, it first go to the right direction, and after that turn back and going back. So from here you will see that for C, time is 20, so time is passing, but position is decreasing, so it means that it turns back 38 meter. So how can you find displacement from A to C? Final position 38 meter minus initial position is 30. Okay, initial one is 30. So you will find the displacement is 8 meter I hat. And another important quantity is distance. Distance is a scalar quantity because the direction is not important. Only you will find a number, and distance is the length of a path followed by a particle. For example, from A to B, you must take the absolute value. What is the distance? 52 minus 30, 22 meter without any direction. I hat, J hat, K hat. Okay, you don't need to put direction because this is distance. Only this is a scalar quantity. And from A to C, what is the distance? For this one, you must calculate separately all the path. First, you must find between B and A plus C and B. B and A is, we already found it, 22 meter. And between C and B is 38 meter minus 52 meter. But this is, you will find negative, but always you must do positive because this is scalar quantity and only important is length. And when you add it, you will find 36 meter. So as you see that the displacement from A to C is 8 meter I hat, but distance is 36 meter. So they are different to each other. So displacement and distance are different to each other. One of them is vector, another one is scalar quantity. So we have many examples. Let's look at this example. This example is in 2 dimensions, which we study next time. But here it is very simple, and already we study vectors. So you can do it by using the vector rules. In this example, there's a rabbit runs across a parking plot on which a set of coordinate axes has strangely enough been drawn. The coordinates in meters of the rabbit's position as a function of time t are given by. So they give you the position of the rabbit as a function of time t. So when time is increasing, the position is also changing. So position is not constant. So at t equals 15 seconds, what is the rabbit's position vector r in unit vector notation and in magnitude angle notation? So magnitude angle notation means you are going to find magnitude and direction angle. And vector notation means you must write them in I hat, J hat, K hat. Okay, so let's do it. First of all, you must write this vector in unit vector notation. So R vector is equal to x I hat plus y j hat. Okay, this is the unit vector notation. So let's write it in unit vector notation. But here, first, but you must calculate it. This is for any t, but you need to find for 15 seconds. So R 15 seconds is equal to minus 0.31 times 15 square plus 7.2 times 15 plus 28. This is for I hat plus, or you can, I will do it here also. If you want, let's do it here because there's no place. X equal to 15 and y equal to 15. So x equal to 15 is, I wrote it here, but let's erase. Let's erase from here. Minus 0.31 times 15 square plus 7.2 times 15 plus 28. This is the x component, and y component is at the t equal 15 seconds, 0.22 times 15 square minus 9.1 times 15 plus 30. Okay, this is the position on the y-axis at t equal 15 seconds. So when you calculate them, x will be, you will calculate it, 66 meter I hat, and y you will find it minus 57 meter j hat. Then in front of the, after the x you put I hat, after the y you put j hat. So this will be your unit vector notation. Okay, unit vector notation means I hat, j hat. This notation is shown to you on vector chapter. Okay, if you look back your study lecture notes, you will see that we already study this notation. Another important thing is find the magnitude. So how can you find magnitude? By using the triangle. Okay, right triangle. So this is x, this is y, this is 90 degrees. So this is r. How can you find it? R square is equal to x square plus y square. So r will be equal to square root of x square plus y square. And then this is the x component, as I said you. The first part is x and second part is y. You put inside the equation and find its magnitude. So magnitude means this, without any direction. And then you must to find angle notation. So direction, how can you find it? You must use theta is equal to inverse of tangent, tangent inverse, y over x, y over x. What is the y? y is minus 57. What is the x? 66. And then by using calculator, you can find it. But here you must be careful, because when you use calculator, you will find 41. But you need to also determine which region it is. So x is positive. So x is positive, so it can be first, second, third, or fourth region. But x, this is minus x, this is positive y, this is minus y. So when this is x positive in the first and second and fourth region, but y is negative, so your rabbit is on the fourth region. So when you find something on the fourth region, some vector on the fourth region, how can you find this angle? Because which angle you need? You need to find angle from positive x to the vector. 360 minus 41 gives you this angle. So this angle will be 319. Oops. 319 degree. Okay, this is also a very important point which we study also in the vectors. Another important quantity is velocity, and velocity is also vector quantity. And what is the velocity? Velocity is the rate of change of position. And velocity has both magnitude and direction. And velocity has a unit of what? Meter per second. So this is derived quantity. And also there are three more quantities which is related with the velocity. So what are they? Average velocity. How can you calculate average velocity? For calculating the average velocity, you must use displacement. Displacement delta x. So if you are only one dimension, you will use delta x. Okay. For three dimension, we use delta r for displacement. For one dimension, we use delta x if you are on the x direction. So if you are on the y direction axis, you use delta x, delta y. If you are on the x direction, z direction, delta z. So when you see delta, it means that displacement. Okay, so so velocity, average velocity is displacement over delta t. And another important quantity is speed. And speed is not velocity. Speed is not velocity, not equal to velocity. And speed is not a vector quantity. Speed is a scalar quantity. So how can you find the speed, average speed? Total distance over delta t. Okay, total distance over delta t. And another important quantity is instantaneous velocity. Instantaneous means when we ask you to find the car velocity for example, at exactly t equal 5 seconds, it means that you must use instantaneous velocity at a specific time. And how can you find it? You must take derivative, dx over dt. So average velocity is displacement over delta t, time. So also you can calculate average velocity from the x position time graph. This is a position time graph. If when you calculate the slope of the line segment between endpoint on a graph, you will find also average velocity. So delta x over delta t, because sorry, the slope of this plot gives you delta x over delta t, and this is the average velocity. And the unit for meter per second, because it is length over time, and it's a vector quantity. And again, if you use the xy coordinate system, right side is positive, left side is negative. But for the average speed, what we use the total distance over time. Okay, so this is different. And this is here, so there's no direction, but the unit is same, meter per second. For example, for here, how can you calculate? What is the average speed? First, you must find total distance. What is the total distance? It moves from its initial position is -4 meter, and final position is 2 meter. So what is the total distance? 6 meter plus here 2 meter minus -4 meter, because this position is 4 meter, here is 2 meter, so it is 6 meter. It position. Here its displacement and also its distance are same, but always you cannot find it same. And time is passing is, let's look at time. This is 1 second. This is 4 seconds. So 4 minus 1 is 3 seconds. So its displacement is what? For this left side, displacement is 6 meter. So what is the average velocity? Delta x over delta t. 6 meter over 3 seconds equal to 2 meter per second. And direction is, it is on the x, so I hat. But for the right side, for this one, its initial position is, which one is initial? 1 minute. Okay. For this one, its initial position is, I think, it is not easy to see here. But if you move 6 meter, 3 and -3, the total distance is 6 meter. Okay. So if total distance is 6 meter, and for example, passing time is 3 seconds, how can you find this? The average speed 6 over 3. So they are not an example, only they give you in the figure, but the real examples are coming in the next slides. So instantaneous velocity is, instantaneous means at some given instant, the instantaneous velocity indicates what is happening at every point of time. So there's a limiting process. So if you take the slope, measure, it gives you the measure rate of change of position. And you can also find instantaneous velocity from the xt plot. And this is also a vector quantity, and the unit is same, meter per second. So it is the slope of tangent line to the xt. So instantaneous velocity vt is a function of time. Yes, you can see the tangent line. And if uniform means constant, uniform velocity is the special case of constant velocity. So in this case, the instantaneous velocities are always the same. All the instantaneous velocities will also equal to the average velocity. So how can you find for the constant velocity or uniform, or how can you find the position when there's a constant velocity? So x final will be equal to x initial plus Vx delta t. So what it means, final position equal to initial position plus initial velocity times delta t. And here you can see that velocity time plot. So velocity is constant, but it's only a straight line. And another important quantity is average acceleration. What is acceleration? Acceleration is the rate of change of velocity. So changing velocity means an acceleration is present. So this is also a vector quantity. So it has both magnitude and direction. And what is the unit? Meter per second square. So what is the equation for the acceleration? Velocity over delta t. So average acceleration is, also you can show it by delta A. So delta A is equal to delta V over delta T, average velocity over delta T. Also there is an instantaneous acceleration. When you see instantaneous, you must take derivative. How can you find the instantaneous acceleration? By using dv over dt. Also, if you find the instantaneous velocity, you can take the second derivative of the position vector to find the instantaneous acceleration, because you know that v is equal to dx over dt. So when you take the another derivative of this one, you will find what? Instantaneous acceleration. But if you want, you can take one derivative of the velocity. It will be same thing. And average acceleration also you can see in this plot. So if there is a acceleration, how can you find uniform acceleration? How can you find the velocity? Final velocity will be equal to initial velocity plus acceleration time delta t. Okay, so let's look at this example. Position given as a function of time. The position of a particle as a function of time is given by. This question is also in 2 dimension, but 1 dimension is so simple, so I choose some 2-dimensional examples. Where r is in meters and t is in seconds. What is the particle's displacement between t1 equal 2 seconds and t2 equal 3 seconds? So how can you find it? This r position vector depends on t. So how can you find at 2 seconds and 3 seconds? Directly, you must put 2 seconds inside. So r vector or if you want, let's say this r1 when t is equal to 2 seconds is equal to, this is a function, so you directly put inside 2. 5 times 2 plus 6 times 2 square, this is I hat, plus 7 minus 3 times 2 cube j hat. When you calculate this, what you are going to find, you will find that it is equal to, let's use calculator. 1 minute. Okay. let's use the calculator. So 10 plus 6 times 4, 34. So 34 I had plus, this is 8. So 7 minus 3 times 8. This is minus 17. So minus 17z. So this is position vector at t equal 2 seconds. Now you must find also position vector t equal 3 seconds. How can you find it? This time you must put inside 3. 5 times 3 plus 6 times 3 square. I had plus 7 minus 3 times 3 cube z. So now you must calculate this one. So let's calculate it. 15 plus 5 times 3 is 15 plus 5 times 3 plus 6 times 9, 69 I had plus. And the second part, 7 minus 3 times 3 times 3 times 3. 7 minus 3 times, yes, it becomes 3 over 4, okay? It becomes 3 over 4. So at the end you will find it minus 74. So minus 74j. So how can you find now particle displacement in 2 seconds and 3 seconds? You find them separately, but now you must find displacement. Delta R equal final position minus initial. Final is T2. So R2 minus R1. So 69 I had minus 74 J had minus R1. So open parenthesis as 34 I had minus 17 J. From here you must do multiply by this minus. What happens? 35 I had minus become positive, and then what you find minus 57 meter j. Also this is meter. So this will be particle displacement. After that you must find particle instantaneous velocity. So how can you find instantaneous velocity? You must take derivative. So this, you know, the position vector. So how can you find instantaneous velocity? V instantaneous, and also after that acceleration. dr over dt. The first part is 5 because there's only one t. But second part is 12t I had plus, there's no t here, 0. Here 3 times 3, 9. So minus 9t square j. So this will be instantaneous velocity. After that you must find instantaneous acceleration. So you must take another derivative of velocity. If you take the derivative of velocity, you can find directly instantaneous acceleration. Let's take it. There's no t after 5, so this is 0. This is 12 I have, and here is minus 18 t j. So there's a t inside, so it means that this is not, acceleration is not constant. It depends on t, time. Yes, we find also instantaneous velocity and acceleration. After that, you must evaluate velocity function or equation and acceleration equation at t equal 3 seconds. So this is now easy because only you put t equal 3 seconds inside the equations. Okay, let's put inside. So v t equal 3 will be equal to 5 plus 12 times 5 plus 12 times 3 I hat minus 9 times 3 squared j hat. And for acceleration, 12 I hat minus 18 times 3 j hat. When you calculate them, A is 12 I hat minus, this is 54 j hat, and unit is meter per second square. Okay, for acceleration, unit is meter per second square, but velocity meter per second. At t equal 3 seconds, what is the velocity? 5 plus 12 times 3 I hat. So here it will be equal to 41 meter per second I hat minus 9 times 9, which is equal to 81 meter per second j hat. Okay, so this is the way to calculate displacement and to also find velocity vector or acceleration, instantaneous acceleration vector by taking derivative, and then evaluate the velocity and acceleration vectors. So there are also special cases. These equations are very important, and always we are going to use them in this chapter and also in the next chapter. So what are they? This is for motion with uniform acceleration. So for constant acceleration. So acceleration is not changing, only velocity and position is changing. So these equations also known kinematic equations. So position from x0 to xt, t is increasing and position is increasing. Velocity is increasing also linearly, and acceleration is constant. Okay, so there is acceleration. So if there is acceleration, you will find your position plot like this curve. What are these equations? So R final, this is final. R final is equal to, so your position vector is equal to R0 is initial position. So in some book also they use RE I hat. So it means that R initial. Sometimes they use R0. It is the same thing for the initial. So R0 is initial position plus initial velocity times t plus 1 over 2 a. A is a acceleration vector which is constant, t squared. And also to find the first equation is position vector. Position vector. Second one is velocity vector. V final is equal to V initial plus AT. And the third one is also velocity equation. And position vector, this is equation as an equation, velocity vector equation. And this is also velocity vector equation, but this is a specific case which you can derive it from the energy conservation. So V final square equal to V initial square plus 2a delta x, or if you are in the 2-3 dimension, you can write it r. Okay, instead of x you can write r, delta r. And if you don't know time and you are going to find acceleration or velocity, and if you don't know the position, this equation is very good. So how can you solve the problems? The best way to gain confidence in the use of this equation is to work a number of problems. The following procedure is recommended for solving problems involving acceleration motion. First, you must read problem, then draw a diagram, choose a coordinate system, label initial and final points, indicate positive direction for velocity and acceleration, because directions are important, label all quantities, be sure all the units are consistent, convert if necessary. So if they give you in kilometer, you must convert it meter. Choose the appropriate kinematic equations. So I show you 3 kinematic equations. So you must choose the best one. And then solve for unknowns. You might have to solve 2 equations for 2 unknowns. Okay, if there are 2 unknowns, you must use 2 equations simultaneously. And then check your result. Let's look at this example. An airplane has a lift of speed 30 meters per second. Lift of speed means this one. After a takeoff run of 300 meters. So what minimum constant acceleration? So you know what? You know the speed v. You know the initial takeoff run means delta x. You know the delta x. So you are going to calculate minimum acceleration. So how can you calculate it? So which equation is suitable? B square. You are going to find A. So inside there must, but you don't know time. So you don't know time. So the equation 3 is suitable to solve it. And they said that minimum you can take the initial velocity 0 and then the velocity is 30 meters per second, so that only unknown is A, so you can solve it. So for the part B, what is the corresponding takeoff time? So which equation is suitable to use it? Now they ask you find T. So inside the equation, there must be time. So you cannot use this one. You can use first and second one. You know delta x. You know A, because you already found it. You can find T. The first one, you know V. You know A. Also you can find T, but V0. We take the V0, 0. So you can use the first one easily because you know V. You know, but if you didn't find the acceleration, yes, you cannot find. It is impossible. But if you find the acceleration on the part A, then you can find T by using the first equation because you know V, you know A. Or you can use delta x. V0 is 0, as I said. So A, you can find T. You can use first or second equation. And this equation is similar to the previous one. So let's solve it numerically. A jet lands on an aircraft carrier at 150 miles per hour. They give you mile per hour, so you must convert it to the SI units. What? Meter per second. In this question, they automatically convert it. So I'm going to use it. So what is the acceleration assumed constant if it stops in 2 seconds due to the arresting cable that snags the airplane and bring it to stop? So you are going to find acceleration A, and they gives you time, and they said that it stopped. So they give you many information. So V initial is 63 meter per second. This is a vector, so I had. And also they said that it stopped, so it means that V final is 0. They give you time is 2 seconds, and they ask you acceleration. So how can you find it? Which equation is suitable? You don't know the position, so it is better to use the velocity equation. So V final equal to V initial plus AT. Okay, so now let's solve it.
Sir, we can't hear you.
Hello, yes. Sorry, someone calling.
Okay.
Okay, so are you hearing me?
Yes.
Yes.
Okay, okay, sorry,
Yeah.
because someone calling me and I use this phone and this trap. Okay, so how can you solve it? I write everything. Now let's put it and solve it. It is very easy. V final is 0. V initial is 63 meter per second I had. A is we are going to find, this is a vector. T is 2 seconds. Take this 63 to other side. When you take it to the left side, it becomes negative. So it becomes minus 63 meter per second I had equal to 2 seconds A. Then divide it both sides to 2. So A will be equal to 63 minus 63 meter per second over 2 seconds. Seconds are cancelled to each other. So you will find that acceleration is equal to minus 31.5 meter I. But here, no, they are not cancelled to each other because meter per second square. This is a acceleration, okay? So they are not cancelled to each other. That's correct. Meter per second. This is 2 seconds. Okay, it become meter per second square I. So this is the acceleration of the plane. This is negative. It means that it is decelerating. Okay. And part B, if the plane touched down at position x initial 0, what is the final position of the plane? So how can you find it? To find it, yes, we find that A is equal to minus 31.5 meter per second squared I. How can you find it? Now you must use position vector. Okay. First, let's erase these things. Okay. This is V initial 63 meter I. Okay. So to solve the part B, you must use position equation. R final equal R initial. As I said that if you want, you can use R for all dimensions. If you want, you can only use X for X direction. In this equation, it is one-dimensional motion, but I use R for general and then put I hat J hat. R final equal R initial plus V initial T plus 1 over 2 A T squared. This is the position equation and it is vector. So you are going to find final position. So initial position, you can take 0. Okay, you can take the initial position as a 0, RE 0 point as the origin. So V initial is, what is the V initial? 63. So 63 meter I had time. What is the t? T is 2 seconds plus 1 over 2. What is the a? Minus 31.5. What is the t? 2 square. Okay. This square coming from the equation. So now let's calculate. 63 times 2, 126. Okay, 126. But here, this is meter per second. So seconds are cancelled. It becomes meter. I had. Then this part is 1 over 2 times minus 31.5 times 2 over 2. This is 4. 4 over 2 is 2 minus 3 meter I had. At the end, it is 63 meter I had. Okay. So this is the part B. So this is the final position of the plane. Okay, now there are many more problems, and I think it is enough for today. And next time, next week, we'll continue to this chapter, and I will solve you more problems and examples. Okay, so next week, let's continue. So have a nice weekend, and see you next week.
Thank you.
Thanks a lot for
Thank you.
today.
Goodbye.